We are now starting 3.3 day 2, and the focus of today's lesson is going to be about graphs of logarithms. So we've done some work with logarithms already, getting them from exponential form to log form or vice versa. But today we're going to be looking at the graphs specifically and just pointing out some things that we'll need to know about these graphs. So couple of things. We're going to be dealing with mainly our natural log and our common log graph. Remember that for those, natural log has a base of e, common log has a base of 10, so even if you don't see it there, it really is there. And each of these graphs, while they look a little bit different, have some different points involved, one thing you'll always know about a logarithm graph is that it has a vertical asymptote. And so this one's got a vertical asymptote at x equals 0. Both of them in their original form will have a vertical asymptote at x equals 0, and that's the basic one right here as well. This one up here has that vertical asymptote at x equals 0. One thing you're going to be looking for when you're graphing each and every time is to see how that vertical asymptote is shifted, if it is shifted, before you start setting up any kind of graph. So that's something to keep in mind. One that I really want to emphasize here as far as a characteristic of this graph is actually the range of a logarithmic graph. Now, it doesn't necessarily look like this. A lot of people mistake this because you'll see that these lines look like they're really leveling off here as we go this direction forever, but then also we have line going down here. So keep in mind here that the range on both of these graphs, even though it might not look like it, is in fact negative to positive infinity. It does keep going up forever, even though it looks like it really levels off. We will talk a little bit more about the different characteristics as we go along, but that's just to get us started and get us a basis for these two commonly used logarithms that we'll be thinking about graphing, whether it's using transformations of those or whether it's just converting to exponential form on any given function.